So let's take a look at section 2.3, piecewise defined functions. Let's start the section with a definition. Piecewise defined functions are those functions that are defined with different functions on different parts of the domain. So what these are going to be are functions that are defined using more than one function. So instead of a one-line function, there'll be a two-line or a three-line function, and we'll define each of the pieces on a different part of the domain, a different set of x's. In order to illustrate this, let's take a look at an example. Suppose I'd like to graph f at x equals 2 if x is less than or equal to 0, and x plus 1 if x is greater than 0. So the function equals 2 for negative x's and 0, and it equals x plus 1 for x greater than 0. So what your textbook would tell you to do is to first really think of it as graphing each piece using only the domain that's provided. Sometimes what I think is easier for students to do is to actually draw themselves a table for each piece. So the first piece is like having y equals 2 on that particular interval. So what I usually say to students is, well, let's make ourselves a little table. So there's x and y. Now I need to use x's that are less than or equal to 0. So I could use 0. And when I substitute that in, well, y is always 2, so I get 0, 2. I could do negative 1, and that's going to give me 2. Negative 2, that's going to give me 2. And by now we're pretty well convinced into what's going on. So now if I take those points and I graph them, and graph some additional points, I get this blue graph right here. And of course we know that that would run off to the left forever. Now one of the things I'm going to do that's not clear in my diagram is I'm going to address what's going on right when x equals 0. Since in this particular one x can actually equal 0, what's going to happen is that particular point is a closed dot. Well, let's do the same thing for the other piece. This one is going to be y equals x plus 1. And again, I'm going to make a table. And now here I use x's that are bigger than 0. Now, I'm going to say, okay, well, if I pick things that are bigger than 0, I could pick 1, 2, 3. And if I do x plus 1, that's going to give me 2, 3, 4. Now remember, it's everything greater than 0. So I could have actually picked 0.1. And that would give me 1.1, or 0.01, and that would have given me 1.01. What I usually do is when I have this value that says x greater than 0, I usually, just for reference sake, plug in 0, and that'll give me 1. But that's not a point on the graph. So what I usually do is I draw a circle around it, and that reminds me that since it's not a point actually on the graph, that when x is 0, when I go to plot those points, that I have an open circle. So when it's not equal to, I still could substitute the value in just for graphing purposes, but I don't actually reach it, so I do an open circle. So that's really what my notes will say. Technically there's a hole. And then what I do is I graph those two pieces together. And again, the package I use to graph doesn't put the arrows on indicating it goes on forever, and your textbook won't either. But we of course know that it would, because x less than 0 is all of the x's less than 0, and x greater than 0 is all the x's greater than 0. So you'll notice when you look at the graph, there's the open circle. I didn't necessarily put the closed circle on the other one, but I think we kind of get the point. So there's our entire graph.